Hello everyone, welcome to this C programming tutorial. My name is Neha and I am a first year BTech student in the Computer Science and Engineering department at Sri Vishnu Engineering College for Women, Bhimbaram. This video is being created under the guidance of Dr. M. Prasad, Associate Professor in the Department of Computer Science and Engineering at Sri Vishnu Engineering College for Women, Bhimbaram. Let's see my problem statement. Demonstrate dangling pointer problem using a C program. To solve this problem, first of all we should know what is a pointer. A pointer is a variable that stores the memory address of another variable. Coming to dangling pointer, it is a special type of pointer which points to some non-existing memory location. Let's understand in detail with a program. In this program, I am including two header files. First one is stdio.h, which stands for standard input or output, and it is used for performing input and output operations. And the second one is stdlib.h, which stands for standard library, and it is used for performing general operations like memory allocation, process controls, type conversions, etc. We know every program starts with a main, and in that main function I am taking a pointer which contains the address of the first byte of the memory allocated by malloc. Let me tell you that malloc is the function which allocates memory dynamically. After allocating the memory, malloc simply returns the address of the first byte of the memory. I am assigning the value 10 to the memory location that the pointer PTR is pointing to, and with the help of printf, I am printing the value in that memory location, that is 10. After this, I am trying to free the memory, or I am deallocating the memory using this free function. Free function is a special type of function used to deallocate the memory allocated by the function malloc. Let's see the output. You can clearly see that we are deallocating the memory after using the memory. But you should understand this point that pointer PTR is still pointing to the deallocated memory, isn't it? Let's assume that the address of the first byte of the memory is 100, and this address is stored in the pointer PTR, and this pointer points to the value 10. After deallocating the memory or after releasing the memory, PTR is still containing that address. So a dangling pointer points to a memory location that is no longer valid or has been deallocated. This is what's called a dangling pointer. This dangling pointer leads to some security vulnerabilities. So what is the solution for this? For this problem, solution is simple. Just reinitialize the pointer with null. Now this is legal, right? So PTR is no more dangling, and it is important to reinitialize the pointer with null after freeing the memory. Thank you for watching this video.
Hi guys, this is Sarojini from CSE Department of Sri Vishnu Engineering College for Women pursuing first BTech. This is done under the supervision of M. Prasad sir. Here is our problem statement. We have to rearrange the array in such a way that the even places are filled with greatest numbers and the odd places are filled with smallest numbers. Let's get into our program. The aim of our program is to arrange greatest numbers in even places and smallest in odd. At first we declare an array of some large size, and then here n is the size of the array, and ij of loop iterations, and k is for swapping in bubble sort. We are taking the size of the array from the user and also array elements from the user. We created a temporary array of same size to perform bubble sort. And then we are copying the original array elements into the temporary array. Here we can see that we performed bubble sort on the temporary array here. In this way, bubble sort is nothing but arranging the elements of the array in ascending or descending order. In this way, we can separate smallest and greatest numbers, and it would be easier for us to arrange greatest in even places and smallest in odd places. Here we are filling the smallest in odd places. We took j equals to 0 because as we arranged the elements in ascending order using bubble sort, at first it contains smallest numbers, so we are arranging the smallest in odd places. And the remaining half contains the greatest numbers. So we are starting from middle to fill even places with the greatest numbers. Then we are printing the array. Let's run this program. I'm taking size as 5. And elements as 1, 0, 7, 9, 2. As we can see here in input, the greatest numbers are placed in even places and the remaining are arranged in odd places.